Welcome to our first technical deep dive into SQL Fundamentals. Today we'll explore the building blocks of database interactions, the SQL language itself, its various command categories, and how Postgres implement these concepts. At its core, SQL organizes commands into distinct categories, each serving a specific purpose in database management. DDL, or Data Definition Language, handles database structure and schema. It includes commands like create, alter, drop, and truncate that define and modify your database objects. DML, or Data Manipulation Language, manages data within tables through insert, update, and delete operations. DQL, or Data Query Language, focuses on data retrieval, just the select command, forming the foundation of data analysis and reporting. By the way, don't let this apparent small category betray you. Behind the apparent simplicity of a single command for everything lies by far the largest subject in SQL language, requiring several lessons for us to decently cover it. DCL, or Data Control Language, governs database security through grant and revoke commands, controlling user access and permissions. TCL, or Transaction Control Language, manages database transactions using begin, commit, rollback, and save point commands. Think of these categories as different tool sets. Just as carpenters need different tools for cutting, measuring, and joining wood, database developers need different commands for defining structures, manipulating data, and controlling access. These commands shape the structure of your database. Think of DDL as the architect's tool set. It lets you create, modify, and remove database objects. The key commands include create, for bringing new database objects into existence. Alter, when you need to modify existing structures. Drop, to remove objects entirely. Truncate, for quickly removing data while keeping the structure. We'll discuss later on why truncate is not a DML command, it's actually a DDL. Data Manipulation Language. DML commands are your tools for working with the actual data within the database structures. These include insert, to add new records, update, to modify existing data, delete, to remove specific records, and merge, which combines update and insert operations, as it inserts new records while updates existing ones. Data Query Language, or DQL. While technically part of DML, DQL deserves its own category as it focuses solely on data retrieval. The star player here is select. Actually, the only player here is select, the workhorse of data retrieval. Like I said, we dedicate several lessons to mastering select queries. Data Control Language, or DCL. DCL handles security and access control, with two commands: grant, assigning privileges to users, and revoke, removing previously granted privileges. Transaction Control Language. TCL manages the transactional aspects of your database. Begin marks the start point of a transaction. When you're not working with save points, it marks the point of the database state where a rollback transaction will come back to. Commit. This is what makes transactions permanent or durable. The D of ACID, remember that? Rollback. The command used when you explicitly want to undo or revert all changes in current transactions to either its beginning or a specific save point. Save point. To create state points in your transactions that you can revert to. Now that we understand the categories, let's look at how SQL commands are constructed. SQL follows a consistent English-like syntax structure that makes it relatively intuitive to learn and read. This approach is called declarative syntax, which means you specify what you want, not how to get it. Each command typically starts with a keyword that indicates the action you want to perform. SQL exemplifies the power of declarative programming. Unlike imperative languages, where you write step-by-step instructions, SQL lets you describe your desired result, leaving the database engine to determine the most efficient execution path. This is actually an advantage even for performance reasons for the database to understand what they have to do instead of necessarily performing what you want them to do. This abstraction serves both users and database systems. Developers can focus on their data needs without worrying about optimization details, while Postgres Query Planner can freely choose the best execution strategy based on factors like table statistics, available indexes, and system resources. Now that we understand the categories, let's look at how SQL commands are constructed. Here's a basic pattern. We will explore complex queries with joins and subqueries in coming lectures, but for now let's focus on these basic building blocks. This simple query demonstrates three fundamental components: keywords, select, from, and where, that define the operation; identifiers, first name, last name, customers, that specify database objects; conditions, country equals to Australia, that filter results. Select first name, last name from customers where country equals to Australia. It's quite intuitive, isn't it? Keywords are traditionally written in uppercase, although Postgres is case insensitive, so technically it doesn't really matter. Statements end with semicolon. White space and line breaks don't affect execution. White space are necessary to space out your query elements, but once you add one, it doesn't matter if you add more or if you add spaces or line breaks. While SQL is standardized, Postgres extends the language with powerful additional features. Some key PostgreSQL-specific elements include custom data types, advanced indexing options, full-text search capabilities, JSON operations. These extensions make PostgreSQL particularly versatile for modern applications while maintaining compatibility with standard SQL. We'll explore Postgres' unique features in next lesson when we discuss data types. SQL has evolved through several standards, with SQL 2023 being the latest version. While Postgres aims for standard compliance, it also provides unique extensions and improvements. Different database systems implement SQL slightly differently, creating what we call SQL dialects. Think of these like regional accents in a language. The core meaning is the same, but the expression varies slightly. Major SQL implementations include PostgreSQL, MySQL, Oracle, Microsoft SQL Server, and so on. While each has its own specialties, learning standard SQL gives you a foundation that works across all of them. Postgres is particularly known for its standard compliance while offering powerful extensions. Why don't we conclude this lesson playing around with potentially real scenarios? I know there's quite a lot of commands now, but don't worry, we're going to cover them each one in separate lessons. So we are creating a table called orders with a column called order ID, which is a serial number, so we don't need to provide a number, it gets a new one every time we insert a new record. It also contains a customer ID, who made this order, order date, and total amount. In terms of DML commands, we have some insert commands here to insert some records. Finally, we have one select command that is quite complex for now because it actually counts all the orders made by each particular customer based on the customer ID. And also it shows the sum of total amounts. This random example is just to demonstrate how different SQL command categories work together in a typical e-commerce scenario. DDL creates the table structure, DML adds new data, and DQL retrieves summary information. We'll build on these fundamentals throughout this course section, diving deep into each command category and exploring more complex queries and operations. Remember, SQL is a powerful language that becomes more intuitive with practice. Don't worry if some concepts feel abstract now. They will become clear as we work through practical examples in our upcoming lectures.